Hello viewers, welcome back again for another video. This is Math in Motion. Today we are going to talk about the gambler's ruin. The gambler's ruin is a phenomenon where there's a gambler who has a certain amount of money. He starts with a certain amount of money and he wants to, he's playing a game and he wants to win, let's say, M dollars. So he'll either play the game. If he has, let's say, $20, he can place a game. He can place a bet of $1. He can either win the $1 or he can lose the $1. So the gambler's ruin, he can either win, he can either lose until zero or wins the M. That is a summary of the gambler's ruin. Thank you.
Yes, members, welcome back to the channel again. It's me, Shaka Anwar, the math tutor. Now today, as you say that we shall go talk about the gambler's ruin, here we shall suppose an example like a gambler is someone who's playing a game like gambling. We all know gambling. Now for a gambler, he's going to be playing a game. He will win $1 with a probability P. Like if I'm playing a game, you know, all of us who played games like gambling. If you place your bet, you either win $1 with the probability P or lose that dollar with the probability 1 minus P. Now from there, we know that if I start with an amount like set $20, I will stop playing if my $20 are finished. Like if I have nothing to place as a bet, I will always stop playing. And then I'll also stop playing if I win a certain amount of dollars, like M dollars. Okay, obviously when we go for playing such games, we always have the missions, like the missions to win or lose, winning certain amount of money. I shall always play if we are not left to zero balance. That's why we shall keep playing. Then we shall always stop playing if we lose, like if we go to zero balance. Now for this case, we are interested in finding the probability of me accumulating the M of the gambler accumulating the M amounts of dollars, and how long will it take him to accumulate the amount of dollars. Yes, that's what we're going to look at today. Now from that, today let us define our probability. Let us say let AI be the probability of accumulating M, like accumulating M. And then our AI, as we said, this AI means the probability of me reaching M starting from state I. Like I said, I may write like AIM, meaning that I want to reach M starting from state I. Like I have $2 now, but I want to win the M dollars later. Therefore, I can either write it in this format or write it in this format. Now for me, I'm going to use AI. Like AI means the probability of me accumulating the M dollars. Now, the probability of AI me accumulating the M dollars is going to be, from a definition we saw in the previous video, that the probability of me winning $1 times the hitting probability from where I have gone, like the next step I've gone to, up to the M dollar step, like the same thing as having AI plus 1. This AI plus 1 means that I want to be now on the next state, like state AI plus 1, then plus the 2 times the probability of me being on the state before, like I minus 1. Okay, if I try to explain these things, it will be like this. I have like state 1, state 2, state 3, then state 4. That's an example that at state 1, that's when I'm going to be rained. I'm going to have 0 with me. State 4, that's when I'm going to be having my M. Now, if I begin like if I have like $20, I'm at state 3. Then this will also be the probability of me leaving 3 for 4. Okay, if I begin like from 2 to 4, that will be the probability of me leaving state 2 to state 3 with a probability P because I'm winning, and then times the hitting probability from 3 to 4 times the hitting probability from 3 to 4. I think I think I've been doing. That's why I'm saying the hitting probability from 3 to 4. I can either call it A3, 4, or I call it A3. But now remember, my A here was A2. Therefore, my A2, get A3, I have to get this 2 plus 1. That's why I have A plus 1 here. And then if I lose the dollar, I will lose the dollar by a probability 2. Now, the hitting probability from now coming from 1 to 4 is going to be I 4, like this. Sorry, H1 for, because I'm at 34 right now. Now for me, now this is I write this one as A14 over just A1. As we've said that this, I'm just getting the one, the set I where I am at that point. Now, me having this state I here, just meaning 2 minus 1. That's why I have say Q I minus 1. Like where I am after losing, like after losing $1, I'll be taken to a set backwards. That's why I say A minus 1, then up to when I reach to M now again. Now from here, I think I've tried to explain this. If you want to go to this, try to reach me by my WhatsApp number. You have it, and then all the message, the comment section, I'll be able to explain more about that. Now from here, I see that we can formulate a linear differentiation from this question. Like from here, I can have, like, if I bring this A this side, I have my P times A I plus 1, then minus AI, then plus 2 AI minus 1, like that. Now from this step, equaling to 0, because I've brought this I this side. Now from this step, I want to introduce something, and then it's going to make sense to you. If I have P times AI plus 1, then if I introduce like P AI minus 2 AI plus 2 AI plus 1 equals to 0. This statement is the same as this statement, but just this statement up here, it means that if I have negative AI, and then I have negative AI into P plus 2, this is the same thing as having negative AI P minus AI 2, and then this is the same thing I have in this. Instead of me having negative AI, I have just negative AI minus this value here. And then remember, P plus 2 is always 1. Therefore, I will always take this example of mine to be my difference equation. Now, I want to take you through how we solve a difference equation using the method of difference equation, like solve a difference equation using the method of difference equation. Now, from there, I think we just need to take some few steps. Okay, I want to just do an example on how we solve a difference equation, and then we shall come back to our Gamblers reign. Now, from there, let us just put off this. I first give an example how we solve a difference equation. I'm just making you to recall how we solve a difference equation. And after solving a difference equation, we shall come back to how I will solve this difference equation using that method of difference equations. Yes, now from there, let us take a simple example of a given difference equation, and we see how we can solve it. Now, if I put off this, yes, I think it shall recall this formula, and then we see. Now, remember, let us take an example of a difference equation and see how can we solve the difference equation. Now, if we have like xn plus 2 minus xn plus 1, then minus 6xn equal to 0, and then we have our x, like x not equals to 3 and x1 equals to 4, and we are given x not equals to 3, and then x1 equals to 4. Now, how do we solve for this difference equation given these conditions? Now, the step one for solving a difference equation, we have to let, like step one, we say we let our xn to be the same thing as having what? Lambda n, lambda power n. This is the first step we have to do. We let our xn to be lambda power n. Now from there, if we let our xn to be lambda power n, then I just substitute into this first question. Also now, I have lambda power n plus 2 minus lambda power n plus 1 minus 6 lambda power n equals to 0. Yes? Now if I divide it through by lambda power n, if I divide it through lambda power n. What do I remain with? I'll have lambda squared minus lambda n minus 6 equals to 0. I'm dividing through by lambda power n. Now from here, I'm able to find the values of lambda 1 and lambda 2. Now if I find the values of lambda 1 and lambda 2, what's going to be my lambda 1? What's going to be my lambda 2? My lambda 1 is going to be negative 2 and lambda 3 is going to be, I have negative 2 here, then I have negative 3 this side. I have a 3 this side by solving this equation. And those are the values of my lambda. And therefore, I'll be able to generate my general solution. General solution is going to be the same as having, yes. What is the general solution? I will say that my xn will be the same as having c1 lambda 1 power n plus c2 lambda 2 power n. This is the general solution. The steps we will go through when I'm solving a differential equation. Now from there, get my xn. It's going to be the same as having c1 into is going to be negative 2 power n plus c2 into 3 power n. But remember now, we're given initial conditions. These conditions help us find c1 and c2. Now from there, we shall be able to see that if n is 0, my unit is 3, my x is 3. If yes, then if n is 0, I have 3 equals to, I'm saying if x not equals to 3, this is what is going to happen. 3 equals to c1 into now negative 2 power 0 is going to be 1 plus negative 3 power 0 is going to be 1 plus c2. This is equation 1. Then now, if x1 equals to 4, then I remain with 4 equals to, now, negative 2 power 1 is going to be negative 2 c1. Then 3 power 1 is going to be plus 3c2 equals, this is equation 2. Now, if I solve these two equations simultaneously, I will be able to find my c1 and c2, where c1 is going to be 1 and c2 is going to be, from solving, c1 is going to be 2, is going to be 1, and then c2 is going to be 2 by solving these two equations simultaneously. Then try to see where I get these answers, and therefore I will say that my xn, what is going to be the value of xn? My xn is going to be c1, which is 1, lambda 1 power n, which is negative 2 power n, and then plus, plus lambda 2, plus lambda c2, which is 2, then lambda 2 is going to be 3 power n. And then here we have solved our differential equation, and then this is going to be our general solution. Now, what to note from this is that if we have repeated if our roots are repeated, I think this is simple. I just want to give what to note before we go in for the gambler's range. Now we've said that our general solution for a differential equation. So I say that if our lambda 1 and lambda 2 are real and distinct, we shall say that our xn is going to be the same thing as having c1 lambda 1 power n plus c2 lambda 2 power n. Just like to take an example, if we have only two unknowns, but if they are managed, just say plus c3 lambda 3 power n up to. Now, if our lambda 1 and lambda 2 are just what are repeated roots, like lambda 1 equals to 1 and lambda 2 equal lambda 2, then what's going to be our xn? Our xn is going to be the same thing as having d0 plus d1 d1n plus dash d, this is going to be r, yes, r, then it's going to be r minus 1 into n minus 1, everything times lambda, because lambda is 1, then power n. That way. They just mean not those formulas. Therefore, if we have only two lambdas, I'll just say xn equals to d0 plus d1, then n into the lambda power n. This is going to be our general solution when our lambdas are repeated roots. Therefore, now as knowing how to solve this differential equation, then we can be able to go now and see how we can deal with what? our gambler's reign. Yes. However, allow me to put off this, then go back to our question. Now, if we go back to our question, the gambler's reign. Now, if we go back to the gambler's reign, yes. We've said that our differentiation is going to be the format like we said let the probability AI be the probability of accumulating M. Then we say that our AI will be the same as having P times A plus 1 plus Q. P is the probability of winning $1, Q is the probability of losing $1 into AI minus 1. Let me say that our differentiation question is going to be like P AI plus 1 minus P AI, yes, minus Q AI. I think because these things you have been doing them. Then plus Q AI minus 1 equals to 0. And this negative one is just here, AI minus 1. Like that. I think we call that equation we have been having. And then now this is our difference equation, which resembles the example I've been doing. Now, first time solving this difference equation, the first step we said we let our last time we had xn. Now for us we have now AI. Then we just say let AI equal to lambda I. Then where there is AI, I put there lambda I from this difference equation. Then I'll have I have P lambda I plus 1 minus P lambda I minus Q lambda I. Now plus Q lambda I minus 1 equal to 0. Yes, we are there now. Now from there, we divide through. So divide through by lambda I minus 1 everywhere. And if I divide through by lambda I minus 1, here I have P lambda then squared, because lambda I minus 1 minus I plus 1 is going to be lambda squared, yes, minus now P. Here, remember, I'm dividing by lambda I minus 1. I have P lambda, yes, now minus Q lambda, yes, now plus Q equal to 0. Now, if I find out here P lambda is common, I have lambda minus 1. Then, if I find here I have lambda minus 1 again, then I have here minus Q. I have this thing here, which is 0. Therefore, my P lambda minus Q into lambda minus 1 equal to 0. Yes? Therefore, my lambda 1 is the same as having Q over P, and then my lambda 2 the same as having 1. Yes. Now, this will happen if this P is not equal to a half. If the probability of winning $1 is not equal to a half. Now, if the probability of is not equal to a half, if the probability of winning $1 is a half, then I'll have a half divided by a half, which is 1. Or we call that let our when yes, shall I say this will happen if this one is not equal to a half. And then if the P equals to a half, what will be our value of lambda? My lambda 1 is going to be the same as having 1, because a half divided by a half is going to be 1. And then lambda 2 is going to be 1 also. Therefore, I will have repeated roots for when P is a half. Then I will have unrepeated roots like real and discrete roots when P is not equal to a half. Now, from there, we say now we are going to go now and we see how to find our general solution. Yes. Now, from that step, let us go and see how we get the general solution. Now, shall we begin with if P, say okay, first let, say let my rho equal to Q over P, and then my P is going to be the same as having not equal to a half. Like when P is not equal to a half or rho, now therefore rho is not equal to 1, because if okay, Like, let's just do it like this. If my row equals to Q over P, and then P is not equal to a half, then we shall say that we have real and distinct roots. Therefore, my lambda 1 is going to be equal to Q over P, and then my lambda 2 is going to be equal to 1. These are real and distinct roots we have now. Therefore, our general solution, AI, is going to be the same as having C1 lambda I plus C2 lambda 1I lambda 2I. Just like that. Now, but we know that like our initial conditions are going to be like A naught. What is A naught? And what is AM? Now A naught means what? Is that the probability of me hitting or accumulating M when I'm at 0. Remember, we said if I reach at 0, I'm reigned. Therefore, I won't play the game. Therefore, the probability of me reaching reaching M when I'm at 0 is going to be 0, because I'm already out of the game, because I've gone to 0. Therefore, probability is going to be 0. And therefore, AM means what? The probability of me reaching M when I'm at M, like probability of getting M when I'm at M. Therefore, the probability will be 1. Therefore, I will have a 1 here. Therefore, these are going to be our conditions to use so as to find the values of lambda, value of C1 and C2. Now, if I try to substitute, I have A1, AI is going to be the same as having C. Now here, because lambda 1 is now Q over P, but I've called Q over P to be mu, I have mu I, like that. Sorry, not mu, lambda I. Sorry, this is rho I. Now plus C2 times lambda 2, which is 1. 1 power I is going to be 1, like that. But now, we know that A naught is 0. Then if A naught is 0, I have 0 equals to C1 mu, rho power 0 plus C2. Then I have my 0 equal to any number power 0 is going to be 1. Then I have C1 plus C2. And therefore I say that C1 equals to negative C2. That's equation. This is my equation 1 from this first thing. Now from there, if I put now AM, I have 1. I have now 1 equals to C1 rho power M, now plus C2. Yes, but now from equation 1, I know that my C1 goes to negative C2. Therefore, C2 equals to negative C1. I'm saying now my 1 equals to C1. I'll say C1 rho M, then minus C1, because from this equation here, I have something like this. Now, if I try to here, I have C1 into C1 into rho power M minus 1 equals to 1. Therefore, my C1 is going to be the same as having 1 out of minus 1. I go together, rho M minus 1. This is going to be my C1. Therefore, my C2. Therefore, my C2 will be negative of C1. I'm going to have negative 1 out of rho M minus 1. And therefore, I'll be able to find my AI. Therefore, my AI will be the same as having C1, which is 1 out of rho M minus 1. Yes. Now, plus times, remember times rho power I from this equation here. Then plus C2, which is negative minus now, minus 1 out of rho M minus 1. And that is the AI I have. But now I want to make AI in this format. Now, if I try to introduce negative here, I'll have negative rho I. Then if I introduce negative down here, I'll have now divided by 1 minus rho M. Then if I try to introduce negative here, I have a plus here, 1 out of negative down here, which is 1 minus rho M. Then I have my AI as 1 minus rho I out of 1 minus rho M as the probability of me accumulating M when my P is not equal to a half. This is going to be my probability of me accumulating M when my P is not equal to a half. This will happen if the P is not equal to a half. And rho equals to Q over P. Now from there, I think we can now look at what will be the probability my A when now my P is a half. What will be the probability of me accumulating when P is a half? Yes. Now let us go ahead. When P is a half, what do we do? You know, we said when P is a half. We said when P is a half, means that rho equals to 1 because it is q over p. When q, remember our rho is q over p. When p is a half, yeah, therefore this is also a half because q is always 1 minus p. Therefore, if I divide half by half, I'm going to have the 1 here. Therefore, from there, we shall just know that our lambda 1 equals to 1 and then lambda 2 equals to 1. And therefore, these are repeated roots. When we say that now our general solution AI going to be the same as having d naught plus d1i times lambda power I. But remember, we have our solutions that a naught is 0 and then am is 1. We said that a naught is 0 because if I reach 0, I want to be able to play the game. Therefore, I want to accumulate m, and then am is 1 because if I'm at 1, therefore the probability of winning 1 is going to be 1. Now, as substituting into this equation, I have 0 equals to d naught plus d1 into 0. Then lambda power 0 is 1 power into, okay, 1 power 0, which is 1. Therefore, I have 0 equals to d naught because d1 times 0 is going to be 0. Now I have my d naught equal to 0. Now, if I substitute in m, I have 1 equals to d naught plus d1 times m into 1 power m, but 1 power m is always 1 because any number power 1 is going to be 1. Then I'll have that this is d naught is 0, I have 1 equals to d1 m. Therefore, my d1 is going to be the same as having 1 over m. Yes, we are together on that step also. Therefore, I will write my AI as d naught, which is 0, plus d1, which is 1 over m, like this, times, 1 over m, not I over m, 1 over m, then times lambda, which is 1, times power I, which is 1. 1 power anything is always 1. Therefore, my AI is going to be the same as having 1 over m. Sorry, I'm saying if we write our AI from this equation here we have here, d naught is 0, now plus d1, so it should be 1 over m, 1 over m, but then times I, then the I will come here up. 1 over m times I, so it should be I over m. Yes? Now times lambda, which is 1, power I, which is 1. Therefore, 1 power I is going to be 1. Any number power 1 power any number is always 1. Therefore, my AI is going to be the same as having I over m. Meaning that I over m if the P is a half or rho is 1. And therefore, I can conclude that my probability of accumulating m is going to be, accumulate now is in general form like AI. The probability of me accumulating AI, I want to accumulate m the same as having I over m when P equals to a half or when rho equals to 1, and then it's going to be 1 minus rho I over 1 minus rho m when P is not equal to a half or when rho equals q over m. So q over p. And remember, the I means that the amount of money you began playing with, and the m is the amount of money you are willing to get, like you are playing to get. And then this is going to be our gambler's reign. I think members have tried to explain and explore everything in the gambler's reign. I think in the next video shall be talking about how now to get to know how long will it take the gambler to accumulate the m in the next video. Now for today, let us just appreciate this and try to comprehend it and understand it. And members, thank you for watching the videos. I'm appreciating also, but members, you are lacking in commenting and liking the videos. A video may have some more likes, like 400, but it has like 5 likes. Why, members? Members, endeavor to like the video as you are watching, and not forgetting that this coming week, Wednesday, we are voting for Nyan's Trevor for Chairperson Musa. I personally am not vote for him, and I request you, my viewers, my dear viewers, to also vote for Nyan's Trevor because he's helping the channel. He provides markers, he provides everything, and members, endeavor to vote for Nyan's Trevor for Chairperson Musa. I remain Shaka Anwar, the math tutor, and I think we shall be together in the next video as we are talking about the time taken for the gambler to accumulate the M. I think for this we are able to appreciate, and we shall see you together. See you soon in the next video. I mean Shaka Anwar, the math tutor.